Okay, so let's look at homework number 1. I want to go over the answers with you and video this. That way, just in case if you need it, so that way you can go back over it. I'm also going to take pictures of the answers, so that way you can have it that way as well. Okay, so let's look at homework number 1 from Unit 7. First, here we have our chart that they're asking us to complete. They would like to know the number of valence electrons, and where do we get that? We get that from the group number, right? That's at the top of those columns. We need to know the oxidation number or charge, right? They want to get to the octet rule. So either they're going to gain electrons or they're going to lose and get rid of electrons. It says here, is it a metal or a non-metal? That's pretty easy. The metals are pretty much on the left side of the periodic table. Non-metals are pretty much on the right. Cations are anions. So due to the oxidation charge, if it is a positive charge, it's a cation. If it's a negative charge, it's an anion. Okay, so now that I wrote a few notes here, let's go ahead and let's look at this. Sulfur. Sulfur, if we go and look at which group it is, sulfur is in group 16. So the number of valence electrons is 6. The oxidation number. Well, it's easier to gain or add 2 more electrons to get to the number 8 than it is to get rid of 6. So it's going to be a -2 charge because they're going to add 2 extra negative electrons. And so it's going to have a bigger negative charge than it is positive charge. Sulfur is a non-metal. And because it's a non-metal and because it's a negative charge, it is a anion. Let's keep going. Aluminum. Aluminum is a metal. It's in group 13. So it has 3 valence electrons. The fact that it's a metal means that it's going to have a positive charge and it's going to be a +3. Okay, because it's easier to get rid of 3 electrons, and so it's going to have 3 more positive protons than it is compared to negative electrons. It's a metal. It's a cation. Chlorine. Chlorine's in group 17. So 7 valence electrons. It is a non-metal, which is going to make it have a negative charge, which is the -1. Okay, it's easier to add 1 more valence electron than it is to get rid of 7. Non-metal. And that makes it an anion. Neon. Nitrogen. Nitrogen's in group 15, so 5 valence electrons. It's easier to gain 3 negative, so it's going to have a -3 charge. It's a non-metal, which is an anion. Oxygen is a non-metal, which is in group 16, so 6 valence electrons, a -2 charge. It is a non-metal, and that makes it an anion. As a quick reminder also, just to help you out, cations are going to be metals. Anions are nonmetals. That's just kind of like a little rule there. Alrighty, now let's keep going. What type of bond is formed when 2 ions attract to each other? We call that an ionic bond. Okay, they said the word attract to each other. Attract, think of it as a magnet. A positive and negative in a magnet, they're going to attract to each other. If they use the word share, then it would be a covalent bond. But they did not use the word share. They used the word attract. When they say the word attract, think of magnets, and magnets have a positive and negative end, just like ionic bonds. There's a positive and negative side of it that attract to each other. Let's keep going. Number 3. Now draw the ionic compound formed from the electron dot structure of each of the following pairs. So they would like you to do the full long, it was on page 1 in our notes, okay, drawn out part of it, okay, nothing with the crisscross. So let's look. We have aluminum and we have sulfur. So let's go ahead and I'm going to draw aluminum and I'm going to draw a sulfur atom. Now when they bond together, aluminum, it's in group 13 and it has 3 valence electrons. Let me draw those in. 1, 2, and 3. Now sulfur is in group 6, and I'm going to go ahead and put 3, and I'm going to put 6 because it's in group 16. 1, 2, 3, 4, 5, 6. Now what's going to happen here is that aluminum is a metal, and metals like to donate electrons. Sulfur is a non-metal. It likes to accept electrons. So aluminum is going to get rid of one, and it's going to give it over here to the sulfur. And this electron is going to get rid of it, and it's going to come over here to this part of the sulfur. Okay, there's a problem. We have the sulfur who is happy, who's been able to reach the octet rule, but aluminum is not happy because they still have one extra electron that they want to get rid of. Okay, so something has to happen. Well, we're only bonding those two atoms, so let's go ahead and draw another sulfur over here. And I'm going to draw it over here. Again, in group 16, 1, 2, 3, 4, 5, 6. And so now this aluminum over here can get rid of this electron, draw it over here, and now this aluminum is happy. There's a problem. My sulfur right here has one extra spot, and it needs one more electron. Okay, so the only two things I can work with is aluminum and sulfur. That's what it says. So let's go ahead and draw another aluminum atom. So I'm going to go ahead and draw this one over here, aluminum, Al. Again, in group 3 or 13, so 1, 2, 3, this aluminum electron, valence electron, is going to leave and go to the sulfur. A problem? We have two more. Something needs to happen. So let's draw another sulfur. I'm going to draw another sulfur over here. 1, 2, 3, 4, 5, 6. The aluminum valence electron is going to leave, go to the sulfur. He accepts. This electron is going to leave and go to the sulfur, and the sulfur is going to accept it. And look, the octet rule is complete. The octet rule is complete. The octet rule is complete. It's complete, and it's complete. Now we're happy. We're good to go. Okay? This is the long drawn out electron dot structure, drawing it out. Okay? Now they have calcium and selenium. Okay? Let's go ahead, and calcium is in group 2 and selenium is in group 6. Okay, so let's draw a calcium atom and a selenium atom. I have 2, 1, 2, selenium 1, 2, 3, 4, 5, 6. Okay, so what's going to happen here is now my calcium, who is a metal, is going to donate. My selenium, who is a non-metal, is going to accept. So calcium, get rid of this valence electron. Calcium, get rid of this valence electron. Selenium has 8. Calcium got rid of the 2. So now they're happy with their octet rule, and we're done. Okay? Let's keep going. Sodium and nitrogen. Sodium is in group 1. Nitrogen's in group 5. Na1. Nitrogen 1, 2, 3, 4, 5. And what's going to happen? My metal is going to get rid of because it donates, and my non-metal accepts. So I'm going to donate over here. Are we done? No. Nitrogen needs 2 more electrons to be happy. So let's go ahead and do another sodium over here. And he can donate 1. And if I draw another sodium, he's going to donate that one over here. And now what happens? The nitrogen is happy because it has a full valence shell. The sodiums are all happy because they got rid of that extra one on the outside. And their octet rule is also complete and happy. Okay? Let's go to the next one, which is number 4. Number 4 says, write the formula for the compounds in number 3. 1, 2, 3. So let's go ahead and do those. So the formula, okay, the formula is whenever we write it out and we do like the crisscross and everything, okay? So let's do that. We have aluminum and we have sulfur. So I'm going to put Al and I'm going to put an S for sulfur. Now I need to have the charge, okay? So aluminum has a charge over here, which is going to be, what's going to happen? It's going to get rid of, so it's going to have a +3 charge. My sulfur over here is going to have a -2 charge. The charges numbers are different from what the group numbers are. All right. If his group number is 6, he needs 2 more negative electrons to have an 8, and he'll be happy. We crisscross. He comes over here. He comes over here. So now my answer is Al2S3. 3. This has a metal. It's an ionic bond. What do we do with ionic bonds? Do not forget, you need to reduce. I cannot reduce a 2 and a 3 anymore. But look at this. 2 aluminums, 1, 2, 3 sulfurs, 1, 2, 3. Our drawing came out perfect, and here's our crisscross method, shortcut method. Let's go to B. B is calcium because metals go first, and selenium. Now calcium has a he has a +2 charge, and selenium has a -2 charge. We're going to crisscross those, okay? And now when we crisscross those, it's going to be a 2 and a 2. But what do we do with ionic bonds? We reduce. So instead of writing a 2 and a 2, it's going to be CaSe, and we're done. Okay? Does it mean there's a 1 and a 1 here, a 1 and a 1, because it was reduced? Just look at that, how perfect it worked out. Yes, we must reduce, and look how that is, a 1 and a 1. If we had a 2 and a 2, I mean, why do 2 and 2? Because 1 and 1 is good enough, and we can see that it's already full, it's complete, they're happy, and there's no reason to draw an extra calcium and selenium. That's why we reduce. Next one. Sodium and nitrogen. Sodium is a metal, so it goes first. Na. Nitrogen is a nonmetal, it goes second. Okay. If I come over here, sodium is in group 1, so that's going to be a +1 charge. Nitrogen is in group 15. He needs 3 more, so it's a -3 charge. I'm going to crisscross those, and so the 3 comes down in the 1. Na3N. How many NAs? 1, 2, 3. How many N's? 1. Perfect. Let's keep going. It says here, write the formula with the ionic compounds here. Make sure you use the crisscross method. So let's do that. First thing is, we need to make sure we write our charge. Strontium is a +2. Nitrogen is a -3. Crisscross those. And in this case, it's going to be Sr3 and 2. I cannot reduce that anymore. Alrighty. K, potassium is a metal. It's a +1 charge. Iodine is a nonmetal, -1 charge. Crisscross those. We do not write a 1. We leave it blank, and it's understood to be a 1, invisible. Ki. We're done. Magnesium is going to be a metal, so it goes first. That's a +2. Oxygen is a nonmetal, which is a -2 charge, but we need to crisscross those over. And when we crisscross them, what do? We need to remember that we're going to have to reduce. So I'm going to put right here, reduce. Okay, so we need to reduce that. And so once we crisscross them down, MgO, we're done. Potassium and sulfur. So let's come over here and look at potassium and sulfur. So potassium has a +1 charge. Oops. Sulfur has a -2 charge, +1, -2. We're going to crisscross those over. Okay, and so in this case, K2S. Alrighty, let's keep going. Calcium and oxygen. Alright, so +2, -2. +2, oops. -2 charge, right? Let's go ahead and crisscross them down. And what happens when we crisscross them down? Then we're going to have to, and I'm going to write it over here, reduce. 2 and 2 is reduced to a 1 and a 1. So CaO, we're done. Ba is a +2. Beryllium. Chlorine is a -1. Oops, I meant to do that in green. Crisscross those down. So in this case, we're going to have Ba, because of the 1, we're going to leave it alone, Cl2. Okay. Sodium is a +1 charge. Sulfur is a -2 charge. Crisscross those suckers. and it's going to be Na2S, and we leave it alone. Aluminum is a metal, so it's a it's a +3 charge. Oxygen is a nonmetal, -2 charge. Crisscross those down. I cannot reduce a 2 and a 3 with each other, so it's Al2O3. Okay, so there goes the answers. I'll take a picture as well and post it. I know we've already talked about it, but just in case if you wanted to see me work out the problems, I'm going to do that for all the homeworks, okay? Alrighty, have a great day.